Welcome back everyone, my name is Naveen Reddy and in this video we'll talk about blockchain architecture. So we have talked about the basics of it, right? We have talked about hashing, we have talked about Merkle tree. Now we know the prerequisites for blockchain. In this video, let's focus on the architecture of it. Now when I say architecture, I'm talking about what exactly blockchain means and what is that inside each block. So let's start with it. Now blockchain is simply a database, right? Of course, a lot of people have a lot of expectation from blockchain. They feel blockchain can solve all the issues. Not exactly. Blockchain will solve issue based on data, right? So the issue nowadays we have is we can manipulate data, and plus we also want to make sure it is distributed. And that's what we can achieve with blockchain. When you say a block in blockchain, you have data. So now what kind of data I'm talking about? Now as blockchain type changes, we have different types of blockchain, which we'll talk about that later in detail. But the moment you talk about different blockchain, they will have different set of data. Now one of the blockchain which is very famous is public blockchain, in which the example is Bitcoin, right? The first blockchain implementation. Now the Bitcoin block will have what? Now we use Bitcoin to send money, right? So of course it will have from, it will have to, and the money as well. Now that is the data which you save in a block. Now with this data, you have one more thing which is known as the block header. Now why do we need a block header? The thing is, you will be having a lot of blocks, right? So how can you differentiate between each block? And how can you create that chain which I'm talking about? And that's where the block header comes into picture. So what this block header will have? First thing we need is every block need a timestamp, right? That's important, right? If you don't have a timestamp, how do you know at what point or when this block was created? So we need a timestamp. The second thing we need is a version, right? Now we have different versions of blockchain or the protocol which we use. So that's one thing you will have. So you will have a timestamp, you will have a version, and then we'll also have a Merkle tree. Now if you remember, we have talked about Merkle tree, right? So in one particular block, you'll be having a lot of transactions, and then you need only one hash of it. And that's where we will need a Merkle root. So we need a timestamp, we need a version, and a Merkle root. Now what else? Now we need two more things. The moment you talk about public blockchain, one of the algorithms which is very famous is proof of work. Again, we'll talk about that later. But then if you want to verify the block, we have to use POW, which is proof of work. And to make it work, we need two more fields. First one is the difficulty target, and second one is nouns. So we'll talk about that later once we talk about the proof of work. But as of now, we need these two fields as well. Now we have talked about 5 fields. So in a block, you'll be having this 5, but we'll have one more, and that is your previous hash. Now what a hash I'm talking about? Every block will have a hash, right? How will you create this chain? Every block will have the hash of the previous block. So example, let's say if you have 5 blocks now, so second block will have the hash of the first block. The third block will have the hash of second block. The fourth block will have the hash of third block, and that's how you create a chain, right? You can track backwards, right? So let's say if you are on 55th block, now if you want to know the previous block, of course you have to follow that chain, right? You have the hash of previous blocks with you. Now the question is, what is the advantage of it? If you remember, when we talked about blockchain, we talked about immutability, right? Which simply means once you create a block in a blockchain, no one can change it. Okay, when I say no one can change it, is it password protected or something? What if I say blockchain is open, anyone can manipulate data from blockchain, okay? But why people say it is secure? So let's think about it. Now when you talk about hash, every time you change a data, it will change the hash value as well. So example, let's say if you have these 5 blocks, and then the hash of 4th block is in 5th block, right? The hash of 3rd block is in 4th block. The moment you change any block, let's say I want to change the second block here. In that case, what will happen is the moment you change the data of the second block, it will change the hash as well, right? Now the hash is changing, right? Now it will affect the third block because you have changed the hash value. And that's where problem starts. Because if you change second one, it will change the hash and then it will affect third one. And now again, you have to regenerate the hash for third one to make it work, right? And that's where it will affect the fourth one. Again, you have to do the same thing for fourth and it will affect the fifth one. Now the number of blocks which we have in blockchain is huge. So of course, if you change any one block, you have to change all of those. Is it difficult? Of course not, right? We are living in a world of supercomputer. So what we can do, we can collect thousands of devices with us and you can change the hash of each block. It's not that impossible. But then how can you make it secure now? That's where the concept of POW comes into picture. So every time you change something in a blockchain, or if you want to add a new block, it has to be validated. I'm talking about the public blockchain now. So without validation, you cannot add a block. That means you have to do some processing to add a block, and that's where we have a concept of PWO which says it will take at least 10 minutes for anyone to add a block in a blockchain. Now when you say even if you change one block and if you have 5 blocks, you have to wait for 50 minutes to change the entire block. Okay, that's one thing. It will take a lot of time. Second, your blockchain will not be stored in one machine. It will be there with multiple people. Anyone can be a part of blockchain network. It's not just a central server. So example, let's say in this network, if you have 10 people, everyone will have their own copy of blockchain. Of course, it is a full node. We have talked about that before. So if you have 10 people, when you add a new block in a blockchain, it has to be verified by everyone, right? So everyone will come in consensus to add that block in a blockchain. And that's where we have a concept of consensus algorithm to add data in a blockchain. And that's where you are making your blockchain secure. So first of all, you need a supercomputer to change the block, and you have to wait a lot of time. Plus, even if you want to do that, you need a 50% majority in the blockchain network, which is almost impossible to achieve, right? Because to process that P or W, you need a huge amount of GPUs and CPUs. You can't be that rich to have the hold of 50% of the blockchain network in the world, right? And that's how you make blockchain secure. Now there's one more question. Every block will have the hash of previous blocks. So 5th block will have the hash of 4th, 4th will have a hash of 3rd. What about the first block? Now the first block is known as a Genesis block. Now Genesis block previous hash value will be 0, right? Because we don't have any block before that. In terms of Bitcoin, it was created by Satoshi Nakamoto, the Genesis block, and then based on that block we got new blocks. So that's something you remember. So that's it. That's about the block structure in the blockchain architecture. In the upcoming videos, we will talk about more about blockchain. If you have not subscribed the channel yet, do that for sure. And hit that like button if you're enjoying it. Thank you so much for watching, everyone. Bye-bye.